Assalamu alaikum wa rahmatullah. Uh, Welcome back. So we will start with the next part of our chapter 7, ER diagrams. Let me share with you my slides. ये slides आपको accessible हैं Microsoft Teams में अगर आप general channel में जाएं, so the slides would be under the files menu. So just click on the file menu and you should be able to see those. Okay, last time we covered until this slide. So next we are going to talk about in detail basically the relationships. We talked about entities and attributes and a small portion about key attributes. And now we will look at how relationships are shown in ER diagrams. So let's look at another concept, weak entity types. So there are entity types basically which do not have a key attribute. If you remember our diagram from the company database, we had an attribute of dependent. And in our dependent attribute, we did not have any key attribute like NIC number or social security number or a unique number. We have a name. So based on an employee, that name, likely a person will have his children or dependents different, name differently, not same. तो अपने बच्चों के कोई भी नाम एक जैसे तो नहीं रखेगा, वरना घर में ही confusion होती रहेगी. So that is a weak attribute where the attribute, the entity does not have a key attribute on its own. So in that case, what happens is those entities are identified by a combination of things, two combinations. One is the partial key of that weak entity type. So I said like the dependent is a weak entity type. So in dependent, we have an attribute of name. We can take that one attribute name, and then that particular entity, they are related to, so in case of dependent is related to employee. So employee has an SSN number. In that case, that combination then can provide an identification. So example, let's, I already mentioned it to you, this example in this case. Let me see if we have a picture of this somewhere. Yes, here, right here. So if you look at towards the bottom of this page, middle bottom, you can see dependents of and then dependent. So dependent is a weak identity type, and you can see that this entity is depicted a little differently. The other ones, all of them other have single line, and this one has double line. So dependent has name, sex, birth date, and relationship. Now, none of these are truly keys. There would be many names that could be similar names. But when we take this into context of an employee, then that particular employee, most or in all cases, usually do not name their kids same. So this is one example. Let's go back and look at few other concepts. The other concepts in relationship are constraints. So there are two types of constraints in relationship types. And especially when we are talking about relationship, we are talking about binary relationships. And what are binary relationships? If you recall, in binary relationships, we said that two entities are involved in that relationship, not more than two. So only two relationships, two entities are, or entity types are in that relationship. So those are binary relationships. So one constraint is cardinality. So we need to define that cardinality. What kind of relationship is between two entities? So for example, we have an entity of employee and we have an entity of dependents. Now that you have, I think, studied this, some of these concepts in UML diagrams. So an employee can have more than one dependents. But one dependent, one particular dependent will have, if his or her father is working, then there is one parent or one person that they are, one employee they are associated to as a parent. If we define in this context, now if both mom and dad are working, then that's a different story. But in this particular company database, they have taken this consideration that all dependents are for one employee. One-to-many relationships. For example, the example that I gave you was for one-to-many relationships. The relationship that on one side we have an employee, and other side we can have more than one or n dependents. But each dependent has only one parent. It's like you. So you are taking courses at UET. Now you as a student, one student can take many courses, n courses. But a course and a course can be taken by many students as well, right? So MIS course, let's say. So MIS course can be registered by you. 40 students are in the class, or this is a database course. Sorry, I mixed it up. So database course, more than 90 students are registered. So one course, many students, one student can take many courses. So this is M to N relationship. Now, one-to-one relationships, maybe take an example of a department. So a department can have only one chairman, and university or department or company has a policy that a person can only head one department. So in this case, this relationship would be one-to-one, that the department is headed by one person, and one person can only head one department, not more than one. So this becomes one-to-one relationship. So these are cardinality ratios. The other constraint that is between these binary relationship is existence dependency or participation constraint. So participation constraint, think of a dependent. Now, in that case, an employee can have 0 dependents. So there is optional participation. If he is not married or he or she doesn't have any kids, there is a 0 participation. And then we have participation level of, we can say, mandatory participation, where you must need at least one or more than one. For example, a department. So a department will have at least some number of employees, then it can become a department. Otherwise, there is no department. Let's look at the next slide. This is again cardinality ratio. So now we are going into nitty-gritty details of ER diagrams. What kind of symbols are used? What kind of boxes are used? What are the meaning of double line versus single line versus dotted line versus a diamond shape or a rectangular. So we will look at that. So if you see here, third line, it says that total participation specified by double line. So if there is a double line, then it means the participation is total. And if it is a single line, then it is partial participation. So it could be 0. So here you go. Here is, now let's discuss this diagram in little bit detail. Now that you have grasped some of the concepts of ER diagrams and relationship. Now, if you look at employee, we have employee entity type, we have department, we have project, we have dependent. Now, employee and department, if you look at that, you can see that it's a total, first of all, it is total participation. There are double lines. Second, you can see that it says 1 to n. So 1 to n mean that one department can have more than, up to n employees. So basically, more than one employees. So one department can have n employees. Now, if you go from employee side, you cannot say that one employee can be part of n departments. So if you look at now n to 1 from this side, from left to right, if you read it, then it says this particular relationship says that employee works for one and only one department, because it says n to 1. And the other side, it's 1 to n, which means one department can have n employees. Similarly, if you look at now employee and department managers, let's say, let's take a look at the managers relationship. Now, this is interesting because, see, the policy is, the company has a policy that one employee can manage only one department, and a department can have obviously only one manager. The department could not have two chairmen, department chairmen, or department managers. It is one manager. So we have this one-to-one relationship now. So an employee, one employee. Now this line, if you see, this is a single line, so it is a partial participation. So an employee could be managing 0 department. Obviously, not all employees are managing a department. So this relationship, this single line shows that it is a partial relationship. So one employee is managing one department. From the department side, if you read from right to left, then you can read department is managed by one employee. One department is managed by one employee. So on department side, it is a double line because department must have at least or must have a manager. Now, if you look at works on relationship, in this relationship, you see now this cardinality. So we have studied so far 2 cardinalities, 1 to n and 1 to 1. Now third cardinality is m to n. If you look at this, employee works on project. Now in this scenario, the real world example is that an employee can work on many projects. So one employee can work on n projects, more than one projects. This is the policy of the company. And if you read from the project side, this relationship, then it says that one project can be can have more than one or m employees working on it. So we have this become M2N relationship. This is end-to-end, we can say it, or M2N relationships where both sides are many. So employee side is many and project side is many. Again, I can give you that from employee side there is, if we consider one employee, then that one employee can work on n projects. And if you read from project side, if you have one project, then one project can have many employees working on it. And so m employees could be working on n projects. If you look at department controls project, now on one side it's one, so one department can control n projects, many projects. But if you go from the project side towards the department, then one project is basically managed by or controlled by only one department, not more than one department. Look at the employee and dependent. So an employee can have n dependents, but one dependent can have only one employee that it is dependent on. Similarly, supervision, we will look at this recursive relationship where an employee is a supervisor and then that employee is supervising and employees are working under him or her on one side, and then the other side is that one employee is being supervised by only one supervisor. So this is basically ER diagrams. Let's look at, we'll look at all these notations, what this box means and what this oval means and double line and single line. We'll look at that in a couple of slides. So first, what are recursive relationship types? So recursive relationship is where we see the supervision. Supervision is recursive relationship. You see that there is only one entity that is involved in this relationship, and that entity is employee. So only employee entity is involved, so this is a recursive relationship. So in a recursive relationship type, both participations are same entity type in different roles. So from same entity type but different roles. So one role is supervision role, another role is employee role. So we use this for recursive relationship. Attributes of relationship type. So if you look at now that there are a couple of cases where you see there are attributes that are associated with these relationships, like works on has this hours attribute. So which means that an employee is working on a particular project for a number of hours. So in this particular case, this attribute is only valid when both of these are true. It does not associate with only one entity type. It associates with both of them. Where were we? Let me. Recursive attribute types, alternative min and max notation. So this was one type of ER diagrams where we show M and N and 1. There is another type of alternative notation in which min and max value is shown at the relationship line. So in that alternate way of specifying relationship constraints, basically when entity, let's take an example E. Entity E participates in a relationship and there is at least minimum number of instances that could be there, and then on the other side maximum relation instances. So we will look at those examples on the next slide, how this alternative notation works. Here you go. So now look at this. It is a little bit different than what we were discussing before, where we were saying 1 to n and m to n, and there was no such thing as relationship in such thing as those min and max values. So in this scenario, if you look at two entity types, employee and department, now we are showing in this relationship that one department, so 1 to 1 and 1 is showing exactly that one employee works for only one department. So it is 1 and 1. So it has a minimum value is 1 and max value is 1. On the other side, if you see department, now a department has minimum of 4 employees. So this is the policy of that company, that there must be in each department, there must be 4 employees, 4 to n employees. So n could be any number bigger than 4. So we have now min value, which start with 4, and max value goes to n. Now look at employee manages department. In this case, we are saying that employee manages, so 0 employee can manage, or max 1 employee can manage. So minimum value is 0 and maximum value is 1. So we are saying in uppercase, when we were saying in department, we were saying that 1 employee can work for 1 department. So minimum value is 1 and maximum value is 1. In manager role, now employee, one employee could, maybe there is 0 chance that he or she is not a manager, or maximum 1 value, which is manager of 1 department. On the department side, if you look at, now 1 department has exactly managed by 1 manager, so 1-to-1 relationship. In this way, if you look at now employee and dependent, now employee can have 0 dependents or employee can have n dependents. Employee can have a 0 supervisor or a supervision, 0 to n and 0 to 1. In case of what else is remaining? Department controls projects. So a department can control 0 to n projects, and 1 project is controlled by exactly 1 department. So in this way, we basically explain the min and max type of notation in ER diagram. So it's up to you. Either way, it's fine. In this, this is the second way of showing it. Next slides, basically summary of ER diagram. So here you look at, if we summarize it, then this rectangular shape with single border is entity type. So we define it entity in rectangle. A weak entity is defined as double border. As I showed you, in case of dependent, we had double borders. Relationship. Now relationship is type of a diamond, which we um, have looked at. If you see here, so all those diamonds works for manages, works on supervision, controls. These are all relationships. Identifying relationships. So this is where we had weak entity involved. So in this case, this is identifying relationship, which case was the dependent case. This oval shape with line is attribute. Now key attribute is always underlined, and if it is not a key attribute, it's weak entity, then there is a dotted line. If you go back and look at a name, here dependent has a name which is used as sort of weak key, and that is underlined, dotted underline. And then multi-valued attribute is denoted by double line. Let's see which one is locations. So if you see here, locations is double oval line, which means there is more than one value in locations. Composite attributes, so attribute is subdivided, like we said, was address. So in case of address, it's street name, street number, street. So this is derived address. If you can drive a value, let's say there's a percentage on sales tax. So you have a value and then sales price, and then you can derive the sales tax from, or date of birth. So if you have date of birth, then you can derive age in years. And this is where you have total participation with double line, cardinality ratio with 1 to n, and constraint min max. So all these are relationship ER diagrams. There are other alternative diagrammatic notations, and one of the famous one is UML. You studied that in object-oriented analysis and design. We also studied it in software engineering in detail, class diagrams. So this, I will quickly skim through this part because you have already done this part, the UML diagrams part. So if you will look at the same company conceptual schema in US class diagram notation, then if you see here, we have an employee class, which has at the top, you can see the entity, difference of entity and attributes. Here you have at the top, the entity name is there, then you have all the attributes, and underneath you have functions or operations that are associated with this particular class. Now in ER diagram, we did not explicitly mention, especially in this, in enhanced case of ER diagrams, there are other things that can be added, but so far what we have studied is we haven't included any information regarding those functions or operations. So in this case, employee, you can see in department, we have this relationship 4 and then asterisk. So asterisk is N in ER diagram, we use it. Then 1 to 1 and 0 to 1, and all those relationships are there. Similarly, we have manages relationship and project and works on and dependent. And so all this can be, here is how we can use UML diagrams to show this. So now this, maybe this makes more easier for you to understand ER diagrams from this context, because you have already studied class diagrams in UML. So class diagram, if you convert it into ER, you would pretty much change some of those notations, and then where it says works for, those diamonds will come, and then all those rectangles will come. So you can easily convert it into an ER diagram. In databases, usually we deal with ER diagrams. So far we have studied binary relationships where only two entities are involved in a relationship. So employee dependent or employee projects or employee departments. So in this way, there are exactly two entities that are involved in a relationship. When there are more than two relationship in two entities involved, those are called um, an array or ternary an array type of relationships. So when there is degree is 3, then it is called ternary relationship. So one example of ternary relationship is if we say that there is a supplier S which provides a part P for a project J. So now we have this sequence that S supplier is producing that part P and it is providing that part for a project J. So we have 3 relationships. When we talk about more than 2 entities involved in a ER diagram or in a relationship, it becomes complicated. Usually we use binary relationships, but this is one of the cases that it can happen. Now, if we say that, what if we convert this ternary relationship into 3 binary relationships? So we can take part, we can take a supplier, and we can take project or whatever the third thing was. Project, yes, supplier, part, and project. Now we can show in 3 binary relationship all that relationship, but it won't provide the same meaning. So ternary relationship basically can provide in a little bit more information. Now look at this example. If you see instructor, semester, and course, now this is a ternary relationship where instructor offers course and semester. There are 3 attributes which are involved in this particular relationship. Now we can convert it into 3 basically binary relationship. So how would it be? Instructor can teach course offered during a semester, and instructor taught during a semester. So in this way, we have 3 binary relationship which we are using to as an alternative to a ternary relationship. So there are some other advanced level things in entity relationship model, which are extended entity relationship model, and which provides further specialization and generalization hierarchies, type, subtype, and subset relationship. So those are some advanced level things that are in enhanced entity relationship modeling. But basically, you need to master this ER diagramming, because this is very important, very, very important in database course, in any database course. This is one of the core things that you study and you practice and you get familiar with and you know how to do, because based on that, then you develop your databases and then you have your schema ready for implementation. So next few slides, you can look at some of the examples in these slides. So like in this case, a company is interviewing a candidate. So this we have a ternary relationship type where we have three entities involved, and then interview result in a job offer. So we have these three entities involved in this case. This example, look at airline database schema. Now this one is interesting. So airport, one airport can have flight leg, airport can land airplane type, then type airplane, then leg instance, reservation instance of. So you look at this example and study it in detail. It will provide you much more insight into how to develop ER diagrams. And if you look at all those entities and attributes, you can now think about, okay, what are some of the functional requirements? What are some of the requirements of this business? Okay, so for airline database schema, now we have arrival airport, we have departure airport, we have this flight leg, and then instance of leg instance, and assign an airplane and type of airplane can land at airport. So you can, if you see, you can make this whole one thinking in your brain. Okay, a flight leg, that legs a flight, and then flight has fares, and fares, what kind of fare is it? What is the amount? What is the code? What are restrictions? When is the flight, airline, weekdays, number? So all that information can help you to basically think more. Look at this one. Employee works in a department. Department contains phone, and employee has phone. This is another example of this is also part of the company database example. So employee works in a department. We already had this relationship in our original diagram. Now we have this new phone entity, and we are relating employee with phone and department with phone. Instructor teaches course, uses text. Text is an entity, so text could be books, I believe. Now that would be all the database of a table of books, that book 1, 2, 3, 4, 5, whatever many they are. And then an instructor can teach one instructor. So let's take some scenarios here. So one instructor can teach, we can say, many courses, and a course can be taught by one instructor or many, maybe many. Database course, for example, 2 of us are teaching, I'm teaching, and another teacher is teaching. So a course can be taught by many instructors. So this is M2N relationship. Now a course uses a text. So a database, that's a course, is using a book. There may be other courses which use the same book. So this can also be a M2N relationship. It all depends on the company policy, UET policy. Let's say if UET says that one course can only be taught by one instructor, then that would be a different story. All right, so this is the end of our chapter and ER modeling. So I encourage you all to basically look at all these slides and listen to this lecture. and then be prepared for discussion and questions. Send me any questions if you have via email or via text or via WhatsApp, or we can, during our discussion sessions, we can discuss in detail. So inshallah we will tomorrow meet for discussion. And assalamu alaikum wa rahmatullahi